Hey guys, it's Obi here. Yesterday we were talking about voltage, amperage, and resistance and how it all works together. So just a quick reminder, voltage is pressure, amperage is flow down the pipe, and resistance is restriction keeping the flow from happening. So the voltage is going to push the amperage through the resistance. Today we are going to start talking about a couple schematic symbols so we can kind of understand what's going on as we are reading some circuits. I don't know if you guys got to the point of covering this in science at all. Usually you guys do, but we're gonna go over it just to make sure. So we're not going to cover a ton of symbols, just the basic ones that we will be dealing with. So the very first one we have is a power source. So this is a power source symbol. Specifically, this is a battery symbol. And we can tell we have a line coming in and a line going out, and we can see we have alternating sets of big and little lines, okay? So the shorter side is connected to the ground side. So we see that short line, that denotes the ground side of the circuit. And then the longer line here should be the positive side. So the longer line is what's called the anode, or the positive, and the shorter line is what's known as the cathode, or the shorter side. So this will be used to show a battery. Sometimes they don't do this perfectly. They will use a battery symbol in place of any kind of a load, but for our purposes, you know, a power source is a power source. So really, realistically, this is going to be a battery. So this is two examples of a battery. Here's an automotive battery that we would see in a typical car, and then here's a little battery that we would see in remotes or whatever. Anyways, either one of those are going to show up the same way on this. Usually under the power source there will be a little writing here that says what the voltage is actually on the battery, but not always. Okay, the second thing we're going to see is grounds. So grounds have two different symbols, either look like this or like this, and there are some differences between them, but long story short, they kind of get used interchangeably. So it's if you see a ground, for our purposes, a ground is a ground. So there are two different examples, and they are used when a circuit doesn't directly return to the power source. So on a simple circuit, your power is probably going to go to whatever the load is on the circuit, and then it's going to go directly back to the battery. On a big circuit, like on a vehicle, sometimes it's not practical to send a ground wire from every single system on that vehicle back to the battery. So we actually use the chassis or the frame as a ground. So we will have grounding locations on the vehicle, and then the battery is usually grounded to the engine and to the body or the frame or both. So in that situation, we would use these little grounding symbols to show where it's actually grounded, okay? The next one that we're going to see is a light. So lights are an example of a load in a circuit. This one specifically is an incandescent bulb, okay? And what this is trying to show is the little filament of wire. So if you've ever looked at a bulb closely, you will see that there's a little coil of wire on the inside. And this is actually trying to showcase that component of a light, okay? So this is an incandescent bulb specifically. There are others for LEDs. I don't think you guys are going to see that for a while, so we're not going to cover that right now. The next one we're going to see is a resistor. So anytime you see a little line that all of a sudden becomes jagged and then continues all straight again, that means we have a resistor. So this is always going to be a fixed value. Resistors are used to reduce voltage in a circuit, okay? For anybody that was in the Intro to Auto class last year, if you remember building your LED test lights, we had to use a resistor in front of or in between the power source and the LED, so we didn't provide too much to the LED and burned it out, if you remember. Also, that was something we talked about in the videos that we just watched last week. So this is an example of a resistor you would typically see on a circuit board, or just a a, 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 resistor that we could get to solder into a circuit. without going too far into it, just so we know, the little lines on this actually do mean something. So that tells us what the resistance value is of the resistor. And then the final band, this gold one here, actually tells us what the tolerance is. So this might be a 500 ohm resistor plus or minus 10% or 5% or 2% or something like that. If you need to figure out what the resistor value actually is, you can download on your phone, or you can look online and find charts that will tell you this. I'm not going to make you remember that. Just know that's what those lines actually mean. So, continuing on, we have switches. So a switch is going to connect or disconnect power through a circuit. Should be noted that we typically would expect our switch to be on the power side of the circuit because we want to disconnect power to something. It's typically a safe way to design a circuit that has a switch to power rather than a switch to ground. All right. So anyway, so this switch actually is a single pole, single throw switch, and we won't get into the details of the different styles of switches, but if we see that we have one wire in and one wire out, so it's a single pole on the inlet side and then a single throw on the outlet side, which means we're connecting one wire on the inlet to one wire on the outlet, and that is it. Some of them will connect to 2 outlets, some of them will connect to 3, some of them have 2 outlets. It goes up from here. But a switch is a switch. Okay, so the last big one that we want to talk about is a fuse. So fuses are a current limiting device. Make sure we understand that they are current limiting, not voltage limiting. We can when we see a fuse, they're usually listed as in 5, 10, 15, 20, 25 amps. There's a reason they're not listed in voltage, because the voltage of the vehicle usually never changes much. It does have a little bit different voltage when the vehicle is started versus when the vehicle is running, but the voltage is pretty consistent. Now the amperage draw of the circuit is what we're trying to protect, okay? Because we design our circuit with big enough wires to handle the amperage that we're expecting to see, and we don't want it to go too high above that, or we're going to catch something on fire. So to limit that, we use a fuse, which is going to limit the amount of current. So basically, if something happens that we don't expect, we want this to break before the wire does, okay? So this should always be our first example that we have a problem, which bears the reason that we should probably put a fuse at the beginning of a circuit. We don't want to put it at the end, or it's not going to do a very good job protecting anything. Okay, so here is a couple different examples for fuses. Just know that our symbols could be pretty interchangeable. They can use either one of these. Typically I see this, but this one happens a lot too. So we have a couple different styles of fuse. We have a blade style fuse here. We have a bar style fuse. And here we have a bar style fuse that blowed the heck up. So this is what a fuse will look like. If you look at this and you see one that has a big black spot in the middle and the wire is no longer connected, that fuse is burnt. This one would be blown right here in the middle. Okay, so that's how they control the amount of current. They precisely gauge the size of the wire here, and that wire can only handle 10 or 15 amps of current. And when that overcomes that, it's going to burn. Okay, so let's look at these in a schematic. So this is a really simple schematic. This is kind of what you're going to be dealing with as we're working on this electronics. So this battery is a 12 volt battery. We can see the positive side here, which is the anode, is coming out. It goes directly to our fuse. Our fuse should be the first component in the circuit. All right. We typically follow the fuse. We typically follow the fuse by the switch right here. So the first thing we're going to do is protect any current that goes out, and then the second thing we're going to do is to be able to open up the circuit if we detect a problem. All right. Then from there we're going to go to the load in the circuit. Okay. So our switch is going to send power to our load. In this situation, it's a light. So I don't know if you remembered that this picture here is what we showed being an incandescent bulb. And this is typically the one we would actually see on most schematics. However, I wanted to show you guys this one because this is actually the symbol for light that we're going to see probably tomorrow or maybe the day after. So there is another way when the circuit symbols get kind of small, they usually just show a light like this, okay? So this is another symbol for light. But anyway, so our power is going to come from the battery through the fuse, so battery through the fuse to the switch, and then to the load in the circuit, whatever that may be. And then from there, we have to have a path to return to ground to the battery. So we're going to come back to the battery here, okay? Now, I'm going to show you another example of a circuit, and this is the same circuit with a key difference, okay? So in this one, we still have the fuse, the switch, the light, and the battery, but if we notice, our circuit is not all pretty and neat and does not go directly back to the battery. In this setup, we have a ground here, and that means that this point and this point is technically connected, but they are not physically connected with the wire. So in this situation, this would be, let's say this is the interior lamp on the vehicle. We hit the little switch on our dash to turn the interior lamps on, and then this happens to ground through the body right underneath the dash. And then the battery happens to hook up to the body right next to the battery, let's say. So it's actually, the ground path is actually going through the body to get back to the battery, okay? So when you see a symbol like this, that's what it means when we just put a ground down, okay? Alright guys, so I hope this helps. This is kind of the basic stuff we're going to need to know to be able to begin doing some of the math and understanding some of the circuits, okay? So tomorrow I do believe we're going to be using a trainer, probably do that for the next couple days. We'll see how it goes, okay? All right, Obi out.